Today we're going to be talking about the trapezoidal approximation for definite integrals. Before we were using rectangles to approximate. Today we're going to be using trapezoids. So remember that to get the area of a trapezoid, it's 1/2 the height, and then base 1 plus base 2. Now, in our trapezoid, the height is going to be found along the x-axis. So this is my height, that's my height, another one that's my height. Yes, that's height, height, and all the way down. So remember that those are the delta x's, okay? And if they're distributed evenly, that's b minus a over n, okay? Now, this is base 1, that is base 2 for that trapezoid. So when I'm looking at the area of that first trapezoid, I have 1/2. I'm going to just leave it as delta x. I was thinking about if I wanted to write it h or x, so that's why I had an h there. Delta x, and then we have base 1, and then we have base 2. And then the next trapezoid. Okay, let's assume that our heights, or our delta x's, are even. I have base 2, now I have base 3. So I have 1/2 my delta x, base 2, plus base 3. Continuing along. We have base 3 and base 4. 1/2 delta x, base 3, and let's call that base 4. I apologize, that's kind of hard to read. Plus base 4. And we continue on. And notice how hopefully you realize that all of these bases in the middle are going to double up. When I finally get here, I'm going to call this base sub n minus 1, because I don't know how many I have. Okay, so my last trapezoid is going to be 1/2 delta x, base sub n minus 1, plus my last base sub n. But this base sub n minus 1 is going to be in true trapezoids. It's going to be in this one and this one. And notice how there were a few bases. That was in 2 of them. This guy was in 2 of them. Okay, if I would have written them all out, this one and the trapezoid right before it would have been in 2. So looking at this formula, I can factor out a 1/2 and a delta x. Okay, I have base 1, I have 2 base 2s, 2 base 3s, and continuing on 2 base 4s, all the way to 2 base sub n minus 1s, plus my last one, base sub n. So as long as you have an even interval, you can kind of use this formula base 1 plus base n. So this base, the first one, and the last one you only use once. Everything else you use twice. Okay, so that's in general the general formula. Okay, and using our trapezoidal rule, okay, h over 2, okay, that's what I had. Your first y value the last y value, and 2 of every one in the middle. And again, I highlighted this here, and I'm going to re-highlight it in a different color. These are of equal length, okay? The College Board doesn't like to give you them with equal length, okay? So you know that I am going to be giving you them without equal length. Then you have to do each one of the trapezoids individually. And then concave up versus concave down. So if I'm concave up, concave up, concave up, concave down, concave down. Let's look at whether a trapezoid under approximates or over approximates. So a trapezoid here and a trapezoid here are going to over approximate our area. Versus if I'm concave down, I'm trying to exaggerate it a little bit for you so you could see it. Those would underestimate. Okay, so let's do an example. So in this example, we have the curve y equals x cubed. I'm going to try and get some points on here. And I'm going from 0 to 2. And I have n equals 4 rectangles. So I have, I'm sorry, not rectangles, trapezoids. So that's what my curve looks like. Okay, my delta x, or my height, is 2 minus 0 over 4, or 1/2. Since it doesn't specifically state, but we're assuming that they're equal intervals. So I can use my general formula that I just gave you guys. So drawing in your trapezoids. That would be one trapezoid. Yes, I realize it's a triangle. That would be another trapezoid. That's another trapezoid. That's another trapezoid. Okay? So again, remember, our area can be approximated. So the area is approximately 1/2 the height, f of 0, the first and the last, and f of 2, plus 2 times all of the middle ones. Okay, remember all of my middle ones. That's a middle one, middle base, middle base. So I have 2 times f of 1/2, f of 1, and f of 1.5. So simplifying all that out, I have my area is approximately 1/4. F of 0 is 0. F of 2 is 8 plus 2. F of 1/2 is 1/8. F of 1 is 1. F of 1.5 is 27 over 8. So my area is approximately 17.4. After tomorrow's lesson, we're going to learn how to find this exactly. Okay. And then they need us to find the approximation, whether it's an overestimate or an underestimate. So remember, that deals with concavity. So if my function is x to the third, remember concavity deals with the second derivative, and on the interval on 0 to 2 f double prime of x is greater than 0, which means I'm concave up. So remember, if I'm concave up, it is an overestimate. So it's an overestimate. And you can kind of see that by the trapezoids that I drew in. Okay, you would need this justification here. You would need this justification of the second derivative is greater than 0, concave up. Okay, just drawing me a picture is not going to be enough justification. Okay, speeds in miles per hour, or I'm sorry, miles per second at various times for a test rocket fired upward. Use these values to approximate the number of miles traveled in the first 180 seconds. Round your answer to the nearest mile. Okay, so if I'm finding the area under the curve of speed, that's going to get me the number of miles traveled. Okay, because it's distance equals rate times time. So I'm going to be doing the speed, these heights, times by my time. Now notice how each one of these, okay, the difference here is 20. The difference here between these two bases is 40. And then I have 30. And then I have 30 again. Here I have 20. And here I have 40. So these are going to be my heights here. Okay, and my different speeds. Keep in mind, because these are different heights, I have to break this all out into a bunch of different trapezoidal approximations. So my first one is 1/2 times 20. Okay, 20 is my height. Base 1, base 2. My next one, my width here is 40, and that's for my 0.03 plus 0.08. And there I get 2.2. The next one is 30. So I'm doing my trapezoidal approximation for each one of these individually. So again, you can't use the shortcut here because my delta x is different for each one. And this is what the AP likes to do to us to make sure that we understand what the trapezoidal rule is doing. So I had these two bases, those two, I did my 30, so now I have my 120. So again, these are just each a bunch of individual trapezoidal rules that I'm doing because I don't have the same width. And this one, I don't know why, this one seems really big to me, but I double triple checked it, 21.4. I'm going to check it again because it still doesn't seem right to me. Ah, my calculator. Yeah, that's not right. Okay, I apologize. You guys are, this is really boring for you because you can't see what I'm doing. I should have trusted myself. That isn't right. I think I forgot to divide by 2. So this is 10.7. I've done it now 3 times. Hopefully that's not wrong. So now what I do is I sum all these together. I'm doing that in my calculator. I apologize. I should have checked this before. I thought I did check it. Oh well. And I get my total mileage covered is 30.15. So there is your trapezoidal rule approximation. Oh, I know what I did wrong. I apologize. You guys are all probably all yelling at me. This should be a 4 there because my difference was 40. So this was what I thought it was. That is 21.4. I was wondering why it was half off. So this answer is not right. It is 40.85, and Mr. Jeans would be proud of me. I remembered my units. I didn't remember them up here, and I got a little mad at myself. Okay, I apologize. So that is our trapezoidal rule. Please make sure you have everything that you need for class, and thank you for watching.